Okay, so good morning, everyone. Thanks a lot to all the brave souls that woke up early just to be here on time. For the rest, they'll see the recording, right? So they'll know what they're missing out. So today, we're going to be elaborating a little bit more. I'm sorry for my voice. We're going to be elaborating a little bit more on what we saw yesterday. You saw the introduction into how we can apply DevOps principles into the network configuration management. So today I'm going to go in depth into what it really is. And we are going to see also a nice demonstration on how you can see the reality behind net DevOps, but also how you can just use it and replicate yourself. So how to be the cool net DevOps kid. So I'm going to talk about three things today in this session. I'm going to be talking about the reality of our networks today. I'm going to be talking about how we can apply DevOps principles into the network. And I'm going to be showing you some demos on how it might work. So the first step when talking about networks is that we need to admit that there is a problem. It's not a question of avoiding the situation. As of today, if you think about it, software developers are providing very automated and very quick time to market workflows when they deliver software. You basically just put it into a pipeline, you do a git push, and basically you just get your new software, new feature in production. While from the network standpoint, if there are requirements that you need to accommodate for that software or for that specific feature, it takes weeks. You must think about people saying, okay, yeah, then if we want to do that, we need some additional ACLs, or we need to include some specific specific VLANs in the trunk. You need to configure some specific QoS, and all of that takes time. It's not automatically done. We need to put some time and open some tickets until everything is done. So the reality of today is that networks are functional. They provide connectivity end-to-end for multiple different services, but they're actually considered fragile. It looks like nobody wants to touch anything, right? The feeling is like, don't touch, it's too important, it's providing the connectivity, but if you touch it, it will go wrong. And not only that, the configuration of these networks is considered more of an art than science. It's like, okay, there are certain people that really know how it works. You are not one of them. You don't touch it. It's like, okay, but it should be standardized, right? We have best practices. We have things that should be done everywhere. But in our case, no. You have router jockeys that go and connect and change the configuration, and only they know what they did and why they did it. So it's very funny because it seems that our knowledge of the network relies more on tribal knowledge of some specific key engineers that are kind of the gurus, and they are the only ones that can touch the network. And we would rather just rely on them, and probably you know who I'm talking about. We would rather rely on them to do it, you know, even if they're on holiday and we call them, you know, and they're on the plane, it's like, okay, can you do it before you get on the plane? Rather than having a standardized way of doing things. So, I don't know if you have heard these kind of comments from your customers, but these are paraphrased from actual customer quotes. So, every time we implement a network change, something goes wrong. Have you heard this? Because that's kind of where I'm hearing everywhere. It's like, no, we don't want to touch it. We don't want to do anything because it will go wrong and my boss will kill me. So don't touch it. Let's just keep it as it is. Second line is, isn't it great? Our switch hasn't been rebooted in 6 years. Okay, so is that a good thing? Can you imagine a Windows box that has not been rebooted in 6 years? It talks a lot about the quality of the product that you purchased. But honestly, what about security patches? What about new features that you wanted to implement? How about any changes that you needed to do? So, not the best comment. And the third one, we can't update or change the network. Our business won't allow it. Basically, it's too important. It's providing a service, and we don't want you to touch it because it will disrupt the service, and you will break things, and things will not work as previously, and there will be additional delays or whatever. So, you know, things are kind of static because of this. So it looks like there is a certain aversion to mistakes, like doing mistakes, making things that are not correct. And honestly, if you think about it, maybe mistakes are not that bad, especially if they are small. Big mistakes, yeah, you can get fired for big mistakes. But the problem is that you are doing so few of those that of course they are big. But what if we did many changes so that the mistakes that we did were small because we were doing small changes? So that's kind of the idea here. And it's kind of an idea that relates very well also to software development. Please, if you receive this email, and probably you have received it, saying the uptime for my router, 12.2, my uptime is 11 years. Don't encourage this kind of behavior. This is not good. Again, it's something to be proud of from the vendor standpoint, but it's not good from the operational standpoint. So don't encourage this. The reality of the network today is that due to the fact that we are approaching each one of our routers and sequentially making changes in them and doing them individually, not in a consistent way, but rather me as a jockey just go with my console cable or connecting via SSH and changing the configuration there, and then going to the next one. Oh, there's another problem, I will change it here, and I will disconfigure, reconfigure. Basically, this kind of sequential manual infrastructure provisioning will take us into a network of snowflakes, meaning that each one of them is different from the other. There's no consistency. Best practices go down the drain. There is no way that all of them are consistent. There is no way that anyone with documentation can go in the network and take a look at how it was configured so that they can understand the way that if there is any problem, they should be changed. So it's kind of a not consistent approach into network configuration, and that's what we are trying to alleviate here. So could we apply the same kind of principles that they've been applied in software development with such a big success around DevOps into the network? Because at the end of the day, we are talking about, hey, we need to make sure that we embrace failure. Mistakes are not bad if they're small. Change is good. Changing the network is good. The same as changing the software is good. We want to make sure that we can, collaborate between different teams, basically the proposals, the network engineering departments and the operations teams. We want to offer them empowered accountability, a way to feedback, if something is wrong, how to feedback all across the loop, and obviously to automate the whole process, the same way that we've been doing with software. That's why we call it net DevOps, because we are applying DevOps principles into the network. The idea of DevOps, you're familiar with it, but basically to summarize it here, is the ideology of interoperability and communication between teams. And that's great. Development and operations, in our case, development could be like engineering. So we want to break down silos and create better products. That's great. And then we focus on automation and monitoring. Think about it. How much automation do we have in our networks today? Not much. We are just going there and changing configurations. Our console cable, right? That's our best friend, our SSH. That's the best way that we do things. And I was mentioning it yesterday. If you want to do some changes in your SNMP community strings because InfoSec tells you to do it every week or every month or whatever, you just go there at 4 a.m. and you, with your friends, maybe 5 engineers, go in there and each one of us, we do 100 routers. Repeat the same copy, paste, copy, paste, copy, paste. That's not the way we should be doing things, right? We are in 2019. So the goal is to basically do exactly the same that we are doing for software, but for the network. So we want to manage our networking gear at scale, similarly to the way that we already manage our own servers with UCS, for example. We want to make sure that we provide you with automation. So we want to automate the whole workflow. The software developers of today, they just do a git push and everything is automatically done. We want to have exactly the same for the network. And we want to make sure that we can build, test, and release any of these changes rapidly, frequently, and more reliably in a consistent way. That's kind of the goal of Net DevOps. Everyone with me on the idea? Yeah? Okay, so the idea of Net DevOps is sometimes referred by other people, other companies, other industry parties with different names, but it's the same concept. Sometimes it's called DevNetOps, NetOps, Super NetOps. Well, basically you can just do whatever name you want, right? You can just mix them, DevNetOps, NetOps, NetDevOps, whatever. But it's all based on the concept of network reliability engineer, which in turn comes from the software, the Google approach into site reliability engineer. which is an engineer that knows about the complete workflow and how things work inside the software development process. So here's exactly the same, but for the network. The benefits that we expect from net DevOps is basically reducing the network downtime. Reducing the network downtime is critical. Why? I was talking to someone yesterday night. Since summer until mid-February at least, I'm traveling every week, just talking to customers. And the only question that I ask everyone is, what's the main cause of your network outages? And 90 to 95% of them are telling me that the main cause for network downtime, network outages, is human interaction. Why? Because again, we are humans and we are not good at 4 a.m. changing SNMP community strings in 100 routers. That's basically the reason. So shouldn't there be a way that we can just automate the whole thing so that the system does it for us? The system is good at doing that. We as humans are good at programming our device to talk to the different network elements. So we want to reduce the network downtime. And we want to increase savings as well. Basically, if I have a team of people that are managing one network, I could just use those same people to manage maybe 10 networks or 20 networks, because all the processes could be automated. And we, as humans, would be devising the processes, not executing them. So we want to eliminate organizational silos in between application server and networking people so that everything goes in line and with a consistent time to market. We want to reduce prone to error human intervention, and we want to automate the management. Think about it. If you automate the management of the network, you could have tracking. As of today, if your network fails because of something, do you know who made the mistake of changing the configuration? You have to find first the root cause, you have to find the router, you have to go in there, you have to take a look at the logs, and then you might find, especially if it has not been rebooted, what happened there. We should have a consistent across the network approach into this, right? So, I always like to talk about the culture of fear in which we live today when talking about networks. If you think about it, changes happen rarely in our networks. This means that the changes are big and complicated. If I just change twice a year, of course, I need to change a lot of things at the same time, so changes are big. The team, as long as they only do the changes twice a year, they are not well practiced because it's very rare. The changes are seen as high risk because it only happens twice a year. Obviously, problems occur. Yeah, because if you do things, you commit mistakes, that's normal. But when these problems occur, the change is seen as a failure. And as long as the change is seen as a failure, changes happen rarely. And we get into this wheel, the culture of fear, not to touch anything because you will break it, because the service will be interrupted. So we need to make sure that we can do this change from the culture of fear into the culture of change, in which changes are regular activities. We do them often. As long as we do them often, each change is small. If I change every day or every week, I can do small changes. As long as I do it every week, the team is well practiced. They are not scared. They know what they are doing. The change was tested and verified so we can make sure that everything will work fine. The change was uneventful. There was no failures or minor ones. Then the change is seen as success, and your line of business owners are happy so changes are regular activities. Your boss is not firing you because things are working. Because if you fail in small things. So this is kind of the change from the culture of fear into the culture of change. So how do we do that? Because all sounds great. It's like, okay, why haven't we done this before? So for me, the thing is, we should be treating configurations as code. Software developers are treating code in a certain way, right? So why don't we do the same thing, exactly the same thing, I mean, with configurations? And there is a big difference with something called infrastructure as code. If you're familiar with it, infrastructure as code is not what I'm talking about. Infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files. That means that when you are provisioning in AWS, for example, one specific instance, or in a VPC or some networking there, you just define all of the parameters, and that's the way that you define the infrastructure. And that's great, you include that in your application repo, and you have all of that so that you can just provision resources in the cloud. That's absolutely great. And this is kind of the way that it looks. But this does not count as network as code, or at least it's not enough. This is not what I'm referring to. I'm referring to the actual configurations. So this is something, this is network infrastructure as code, but I'm talking about network as code, which is a different approach. The main difference is that infrastructure as code, as I said, applies to the cloud. And in the repo, the repository where you store the code for your application, you will also include the infrastructure requirements. So you will say, okay, I have created this application, and this application requires in my AWS, in the availability zone, whatever, it requires this specific virtual machine, for example, and this database, and this networking in between the different elements. Oh, okay, that's absolutely fine, and that's infrastructure as code. Maybe you're familiar with Terraform, which is a tool that you can use to automate this kind of creation of infrastructure, and that's fine. And that leads also into CICD pipelines. You can just automate the workflow so that when you include something in this repository for your application, you make a change, it will automatically detonate a workflow that will update the infrastructure in the cloud. And that's fantastic. That's infrastructure as code. What we are proposing is something else. Not a substitute, not an alternative, but something different. It's a different approach. And it's network as code. And the network as code is not only for cloud, but it might be for your own network infrastructure, the on-premises one that you have. So in this case, the repository will include all the configuration files, the ones that you get from the show run, for example, right? Those are network configuration files. Those are the ones that we want to store somewhere. The configuration of your network devices. So all of that will be stored in a repository, and any network changes that you want to propose as an operator will go in Git branches. Basically, you will have a version control system using Git, like software developers, exactly the same. And when you make a change, software developers were doing a Git push. Here, I do exactly the same. I do a Git push for my network configuration change in my own Git branch. The implementation of these changes is done via APIs, meaning that I'm not SSHing into my devices. I have alternative ways of configuring my network today that are much more interesting, consistent, fast. There are other interfaces via APIs, and those are the ones that I want to use. And the repository where I'm storing all these configurations for my whole network is my single source of truth. And this is key. As of today, what is your single source of truth for your network? There is no single source of truth. Each device has its own network configuration, and you go there and you change it. And then you hope that everything works fine, and you're not documenting anything anywhere. And nobody knows who did something on the network. So the repository will act as a single source of truth. So those are kind of the principles of this approach. And of course, this leads to also CI/CD workflows based on the fact that I'm putting all the configurations in a repo. Everyone still with me? Because this is where we are just outlining the foundational stuff. Yeah? Any questions for now? No? Okay. How would the CI/CD pipeline look for the network? So let's take a look at it. We would create a code branch, meaning that we have Git in our system, we are playing with the configurations locally in our computers. We create a branch with the git branch command, so it's standard Git, nothing special. We create that code branch and we propose the change. I change the configuration locally in my computer, I change the configuration and say, okay, let's go for it. I do a git push. Sorry, before doing the git push, what I'll do is I will test the change locally. How are you testing your changes today? When you want to change your network, any volunteer to tell me how do you test your change?
Depends how big you are, but you can pay someone else to do it.
Okay. I always say, yeah.
Lab testing.
Lab testing, okay. That's actually great because you're a lucky guy, you have a lab. I always say that we all have, everyone here, we all have a testing environment. Every one of us, we all have. And some of us are lucky to have a production environment. And what I mean is that we all test somewhere. And if we don't have anything but the production network, our testing environment is the production network. So we all have a testing environment. The problem is that that's not the best approach, right? And think about how a software developer works. They test locally in their computer, they test that everything works fine, and only after that they go and test somewhere else, right? So in our case, we're going to be testing in our own computer. In my case, I'm going to be using NetSync, which is one specific module of NSO, Cisco NSO, the Network Service Orchestrator. NetSync will provide you with the management plane of all the routers in your network. Not the control plane, not the data plane. So basically I cannot do ping or any connectivity testing or nothing like that, but I can check that the syntax of what I'm proposing is consistent. So I will be testing those changes locally in my computer. So I will test a change. I will do a commit, a git commit, standard to my configuration locally, and then I will do a git push. And the git push will just be going into the central version control server, where I have my repo with all the configurations for my whole network, and it will detonate a build. A build is what in software development happens when you detonate with a webhook. Basically it detonates a process. And here it will do exactly the same. It will kick off a build. But in our case, for the network, it will first instantiate a test network. Why? Because we want to make sure that everything works well also in our network. But we don't want to go into our real production network. So how do we do that? We can create a testing network with a simulation tool, like in our case, Viral. I don't know if you're familiar with Viral or Cisco Modeling Labs. It's kind of a simulation of your whole environment with all the interfaces, with all the iOS versions, iOS XE, XR, classic iOS, NXOS, whatever you have. You simulate the whole thing. So this will instantiate this test network and deploy your proposed change, whatever you decided that you wanted to change. It will then run a fully automated test. It will run exactly the same commands that you would run locally. When you change something in your network, what commands do you usually use to run your tests? Volunteer. Ping. Ping, very good. First line. More.
Trace that.
Whatever, yeah, trace route. You will use show IP OSPF neighbors. Show me your neighbors. Show me the BGP routing table. Show me whatever, So all of that can be fully automated. You don't need to do it manually. You can have a system, and in our case it's something called PyATS, that will do exactly that for you. Will run the complete set of tests that you run and more. You can just say, hey, verify that after the change, I have the same number of OSPF neighbors that I had before. Or take a look at the BGP table and check that all the networks are not stale. Or take a look at the VLAN interfaces in my trunk. All of that can be automated. So that's what we will do in the test network. We will report the status. If there was some problem, we will have to investigate the problem and go back to our local staff. But if everything went well, it will go and merge that branch into production, from testing to production, the same way as with software development. The version control server will say, okay, git merge from the testing environment that we created into the real production network. And we will just go back into the flow. We will kick off the build and we'll do exactly the same, not instantiating the test network, of course, but we'll go into the production network and we will deploy the change, run the full test plan and report the status. If everything works fine, we are happy, everything went well. If something fails, the system will automatically roll back all across the network for you without your intervention at all, leaving you in the previous state. So that's kind of the automation that we envision for NetDevOps. So I know what you're thinking. You want to see the real thing, right? Now with slides. It's very easy to show it in the slides. So let me show you what I'm going to demonstrate. If you remember, I was showing this diagram yesterday. Basically, it's the idea of you have your operators. These are the people proposing the changes. This guy is running a Git branch. This lady is running another Git branch. Is kid is running another Git branch. But all of them, when they are happy with the changes, they will be doing a Git push of their branch into the version control server. For the demo that I'm going to be showing today, I'm going to be using GitLab here. You could use basically whatever version control server you want to use, but considering that we have the GitLab people, there's some GitLab people, yeah, that's it. So I'm going to be using GitLab here, and I'm going to be putting all my network configurations here. Via a webhook, this will automatically create an automated workflow, and it will go into an integration server. In this integration server, I have Ansible. Do we have Red Hat people? No? Okay. So we will have Ansible here. It will be detonating an automated process with NSO, and we will be using PyATS for the automated testing. So we will instantiate here a testing environment. As you can see here, it's exactly the same as a production environment, but it's virtual. We will instantiate, we will make the configuration changes. We will run the battery of tests. If everything went well, I will just go and deploy into the production environment, exactly the same changes. Run again the battery of tests to make sure that everything works fine, and report back. Everyone understands the flow? Because I'm gonna go into the demo and it's gonna be not as visual. So I have fat fingers, so I'm not good at demonstrating with typing. So what I've done is last week I recorded the demo for you, so you will see exactly the same as if I was doing it live, but instead of watching me mistype, you will see the real thing. So this is the GitLab environment, and here you are seeing the repo. It's called developer, my username, and CICD 3-tier. It's the name of the folder, the repo that I've created, where I will put all my configurations from all the network devices. So in there, you can see that I have a number of different folders and configurations. As long as I'm going to be using Ansible, I have something called host vars, which is for Ansible, the repository where you store the configurations. So I will just take a look at what's in there, and you will see that I have YAML files for each one of my routers. That's where I store my configurations. So I will just take a look at one of them, for example, core 1, my core router number 1. And you can see that the YAML shows you all the information about security logins, and well, the usual configuration for any network device. So I'm going to take a look specifically at the OSPF configuration. And there's one specific field, the OSPF router ID. So I'm just going to propose a change. Like, hey, I just realized that we have router ID 192.168.1.101. So I'm going to change it from 101, you see it there, to I'm going to edit the file. So I was showing you that it was in the repo as 101. So I'm going to edit the file. I could just be using an IDE, like a Visual Studio Code, for example, but I want to show you, some simple way to work with it. So I'm just going to use my line code, my command line interface with V. So I'm going to edit the file that you saw there. It's in the version control server in the GitLab. I'm going to edit my local copy, and I'm going to change the OSPF ID from 101. I'm going to change it to .1. Okay, so from 101 to 1. That's my configuration change. This could apply to any configuration change all across your network, or for multiple devices. This is just a simple example. So I save it, and then I do a git add to add it into my Git repo. I add that specific file, then I do a git commit. As any software developer, I commit my change, put a comment. I'm changing the OSPF router ID from .101 to 1, and then I do a git push. As any software developer, right? That's what developers do. So my git push is basically sending to the version control server the change that I did in my branch. Everyone with me? Yeah? Okay, so I go to my GitLab just to see if my push got there. So I go there and take a look at the file. And then I see that the OSPF router ID changed, you see, from .101 to .1. So it got there. My git push was successfully pushed into my my test branch. That's fine. So it's there. So then I go and see in the CICD tab, this is the CICD tab, I see that it automatically has created a pipeline. And a pipeline in CICD is defined in several stages. It's me defining them. Okay, I define what I want to happen when this webhook arrives. So in this case, this detonates a pipeline that I have created, and Patrick was mentioning it yesterday. The GitLab file, it's very similar to the Jenkins pipeline file, where basically you just define the steps of what you want to happen. So in this one, I have defined 3 steps. These 3 circles that you see here. When there is a change in a branch, I want 3 steps to happen. The first one, this one, it's called validate, and it's running right now. So this validate stage, it's a linting process. Who knows what linting is for software development? Yeah? Syntax checking. Very good. So we are doing exactly the same here. We are checking that the syntax for our proposed configuration change is good. Again, exactly the same as in software development. So I'm going to do the linting, and the linting is done in a proper way. I'm just executing a container inside the system, inside GitLab. I'm just running a container, and the container, it's going to have an Ansible image, and it's going to run an Ansible playbook with the parameter syntax check. So basically just checking the syntax. That's everything that it's doing. For a certain inventory, development, testing, and production, for a certain configurations. So this is the site YAML. So I'm just doing a syntax check. And at the end, it tells me, okay, job succeeded. Great. So everything went well with this container. So it automatically gives me a tick, and it goes into the next phase. Deploy to a testing environment. You remember I was saying that I would first test in a virtual environment. That's what the second stage is doing. So this second stage, deploy to test, will again run another container. And this container is running the same Ansible playbook, but without the ---- syntax check. So it's not checking the syntax, that was on the previous step. But right now it's actually, executing the changes into my networking testing environment, the viral one, the simulated one. So it's going in there and it's making changes into the devices. You can see that it says for core 1, the one that I changed the OSPF router ID, is saying change. So change 1, it's change core 1. That's in NSO, and that's here in the device itself. So yeah, job succeeded. Everything worked well. It deployed the change. But that does not mean that it was successful by itself. That means that I was able to apply the change. So what's the next step? The third one. Any guesses? What's the third step?
Check the effect.
Exactly, check the effect. Check, verify that your change worked fine. The same thing that you would do manually. I apply the change, I do the commit, and then I check ping or OSPF or whatever you want to check. So that's the third phase. Verify that the deployment to test works fine. So I go and check what's happening there. And again, it's a container. In this case, it's not running an Ansible container. It's running a PyATS container. And the PyATS container is checking everything that I want him to check. So in my case, for example, I check all the different interfaces in all the devices across my network. I check all the OSPF neighbors in all my devices across the network. I check connectivity from all the devices to all the others. I check delays. I check everything. And the system does it for me automatically and tells me if the output is the expected one or not. So it's automatically done for me. So it just tells me pass. Okay, I have gone through 13 critical tests and 13 passed. So yeah, you have succeeded. Everything worked fine in your virtual environment. So that means you are good to go, right? That means that at least in the virtual environment, everything went well. So you are good to go to the production. So I said, okay, that's great. But before going there, I will download some artifacts. Anyone can tell me in software development what are artifacts?
Like your templates and all that kind of stuff.
The templates and also the results. After you run something, you get some output, some outcomes. It might be Docker images that you generate from your Docker files. In this case, the artifacts from a testing phase are some files that I'm downloading here to a zip file. So if I open that zip file, I got an HTML file, 2 HTML files and 1 XML. If I open the log, you will see that you have logs for all the testing that happened there. So you can see here that you have everything that happened, all the testing that I was doing. So you have simple things like the ping test. This is the ping test, and you can see that it passed, it's critical, and I'm telling him, hey, you need to ping from here to here just to make sure that everything works fine. But then you have verify OSPF enablers in this distribution router 1. And in that case, if I take a look at all the underlying commands that it's running, it's crazy. It's not only doing show IP OSPF neighbors, it's doing much more just to make sure that everything is actually fine. So it's the same with BGP and with everything else. But I just wanted to show you the logs because you always have access also to that kind of information in case you want to check it. But the result is that, okay, testing in your simulated environment, it's great. It worked fine. So what's next step? Well, next step is going back to my GitLab CICD pipeline, and the operations people will say, okay, that's great. The change that they proposed went through everything and it worked fine. How do we put that into production? Well, basically I need to go to the merge part, so merge requests, and here I will create a new merge request. I will say, okay, I need to merge from one branch to another. So I have production and testing. So what's the source branch that you would use? Production or test? Test. Fantastic. So I will select here, I will select the test one, and in the target branch, I will just change from test to production. Exactly. I will compare the branches and continue. I will just give it a title, like, okay, I want to propose this change to go to production. I will need to assign it to someone. In my case, as long as the demo I'm running it by myself, I will assign it to myself. But think about a real production environment. It will be assigned to an engineer that works in the operations teams and will be able to do it. So in my case, I assign it to me. That's developer. And I will just submit the merge request. So I submit it, and then someone receives it in the operations team and say, okay, this is great. I can just decide I want to merge it or not. It depends. The operations people will define if they want to do it or not. So let's say that, yeah, they're happy with the change. So they will just click on merge, and it will automatically merge my proposed test branch into the production one. And that will go into the CICD pipeline and automatically create the second. This was the one that we were running, the pipeline that we were running before in test branch. It will create a new pipeline, but this time in the production environment. Yes?
Question on that.
Yeah.
Because in a real network, you have to deal with topology, right? So if you start with the wrong router, then maybe you lose connectivity to the ones behind it, right? So how do you deal with that?
You mean the connection in between GitLab and the production network?
Yes.
Yeah. In this case, you will be connected to all of them in a concurrent way, not sequential, and using APIs instead of SSH or whatever other ways of communicating. So the way that the connectivity that you have to the devices would have to be in parallel. If there's a single pipe, a single bottleneck, or a specific device that acts as a gateway, and that one fails, of course, everything will fail. But usually, from the management standpoint, you have connectivity to all your devices in the network via the management network, which is usually the one that you connect. Not that you do not share the management plane with the data plane, or that's usually the best practice. So might not be the case, but yeah.
But you can change the order.
Yeah, you can define however you want to do it.
Yeah, okay, because I think what Eric's meaning that's not smart to reload your core first, and then try to do the rest while the core's reloading.
But that's why we want to have small changes. And we want to do this in small pieces. You don't want to do a big change for everything at the same time so that if it fails, everything fails. Let's do it in small pieces so that we can just go back and forth. So the pipeline that we created for this production branch, this is the one that actually is going to happen in the production infrastructure. So in this case, we have exactly the same 3 steps. It's exactly the same. The same thing that we did here, we are going to do it here. So if you remember, the first step was validation, the linting, syntax checking. So again, it will run exactly the same container. It will do the Ansible playbook -- syntax check. It will check that the proposed change is good. Then it will go into the second step. And look at this. In this case, the second step, it's got a wheel Anyone can guess why there is a wheel here?
Manual.
Ah, there you go. It's manual. Why? Because in the pipeline, I have defined this as manual. I don't want it to happen automatically. I don't want to be deployed in the network automatically. I want someone to come here and say, okay, I click on the wheel and there is a play button. And I can just actually deploy when I want. If it's 4 a.m., I will do it at 4 a.m. because there is less traffic. But it's manual because I have defined it like that in the pipeline. You can just define it automatic as well. I just wanted to show you, that there is also the option to put these steps as manual. So someone will click on the play, and it will do exactly the same as previously. It will deploy the change to the production network. Instead of testing, now it's to production. So here you see that it's exactly the same. I will deploy into NSO. NSO will do all the abstraction and all the young data models, and then the change will happen in NSO and then go into the actual devices. So you can see core 1 change, and then you can see in the devices core 1 change. It's equal 1. So you can see those changes. So everything worked well, job succeeded. And we go into the third phase. Again, testing, but now in the production network, making sure that everything worked well. So we do exactly the same, we take a look at it, and it's exactly the same. It's the PyATS container. It will just take a look at all the different tests. It will just say pass for all of them. Job succeeded, that means that the change went well. If it hadn't gone well, you could roll back. The system could automatically roll back all those changes from the production network and leave you in the initial state, right? So the system can do everything for you. So with that, the pipeline is completed. You see the 3 ticks. All of this process is completely transparent to the operator. The operator hasn't seen anything. The operator just did the git push. And after 2 minutes, it's deployed in the production network. The complete workflow is automated. I'm showing you how it works in the innards, but it's not like the operator needs to see any of this. We just do the git push and forget about it. So just to verify that everything went well, I will just log in into the actual device just to make sure that the change actually happened, right? So I'm going to do as long as I don't have production environments, I don't have real devices, I will just go there and I will just do a viral SSH into that device, and I will just take a look at the configuration with the so run. So this is the real device, and I will just take a look at the OSPF configuration, and you can see there that the OSPF router ID here. Sorry. Oh, what did I do? You will see that the OSPF router ID is 192.168.1.1, right? So basically the change happened. Great. So that's basically it. And everything went well. So yeah, of course, it was recorded. It was very, very difficult for it not to go well. But this is what you have seen. Basically, you have seen the local environment where I was just doing NetSim, the simulation for linting locally. And then you have my local copy of NSO and Ansible, and my network configurations, my branches. And then I push, doing git push into a GitLab. And GitLab will use exactly the same setup with Ansible and NSO, attacking the testing and production environment. In my case, both are virtual, but that's just because I don't have infrastructure. And then PyATS will do all the verifications. This is the kind of a way that Ansible interacts with NSO, and the kind of value that NSO brings here with the young data models that allows you to abstract all the configuration from the underlying infrastructure, meaning that here you can have different iOS versions, iOS XE, iOS XR, NXOS, different vendors. You might have whatever here, and this is exactly that abstraction layer. And then you have in Ansible the NSO modules to attack NSO. So just to give you an idea of the different components, NSO it's the configuration management tool. It's very comprehensive and flexible. You have all the young data models. It provides you with a single API to your whole network, which is the actual value of the system. And it comes from the acquisition that we did of a Swedish company called KLF. The second element is Viral, the simulated environment. Viral has been available for a long time. The commercial name is Cisco Modeling Labs. And we are just announcing the new version called Viral 2 at Cisco Live, hopefully. that improves a lot of the shortcomings that we have with Firewall. Then you have PyATS, which is a network automation testing tool that we use internally at Cisco to test our own new software releases. When we want to test anything, we use this tool, and it's completely open source and free and available to everyone that wants to use it for their own testing. And it's the one that I was using in the demo as well. If you want to replicate this whole demo end-to-end using a DevNet sandbox and everything, you can just do it by going into this link and get your hands dirty. Everything that you need to learn about, you could even get into the discussion about JSON versus XML or whatever. All of that information is here. In a single link, you have everything and you can learn about it. So yeah, that's basically it. I just wanted to show you the links. And yeah, any questions just before we finish? Any questions at all? No? Great, so thank you.